Okay, so welcome to this video subseries, I suppose you could say, on single area OSPF version 3. I've covered the general characteristics of OSPF and single area OSPF implementation with OSPF v2. Now we're going to talk about v3, which is to say OSPF for IPv6, at least as we're going to implement it in this course. As I mentioned before, there is a flavor, shall we say, of OSPF v3 called address families, which supports both IPv4 and IPv6 within the auspices of OSPF v3. That is outside the scope of this course. So we're going to implement OSPF for IPv4 using OSPF v2 and OSPF for IPv6 using OSPF v3. Let me see. So, OSPF, of course, uses OSPF v3 exchanges IPv6 prefixes, builds an IPv6 routing table. It does everything that OSPF v2 does in terms of building its neighbor table, its topology table, its routing table. It uses builds an SPF tree, builds a linked state database, etc., etc., etc. It is still Dijkstra's algorithm under the hood. It is still doing the same kind of math. The only real difference is how you implement it in what you do in router configuration mode and what you do in interface configuration mode. That's kind of the big difference with v3 versus v2. With v3, you create the routing process, you give it a router ID, and most everything else you need to do in terms of adding networks to the routing process, you actually do in interface mode. And we'll see that as we go along. So let's talk about the similarities. So, uh, like we said, they are both linked state routing protocols. They both use Dijkstra's algorithm, the shortest path first algorithm. They both still use cost as the metric, and that's accumulated exit interface cost on the basis of speed or bandwidth. They both support single and multi-area. Multi-area is still hierarchical. They use the same kind of packets, the same kind of neighbor discovery, the same kind of DR, BDR election process, which we'll see in more detail in Chapter 10, the same router ID. And again, now this is kind of the point at which we really see that the router ID is not actually an IPv4 address. It looks like one. An OSPF v2 router can use an IPv4 address as a router ID, but fundamentally, once we implement v3, OSPF v3 on a router which is only running IPv6, it becomes clear that that router ID is a 32-bit number in dotted decimal notation, which merely resembles a router ID. It is not actually a router ID. Now it is determined by the same process. So on a pure v6 router with no physical IPv4 addresses and no IPv4 loopbacks, you literally have to establish a router ID, specifically, directly, and unambiguously, or you really are not going to get much of anywhere. Now, let's talk about the differences. Okay, so let's see. I'll put myself out here. So, okay, so of course, the most obvious difference is that v2 supports IPv4 and v3 supports IPv6. You wouldn't honestly expect OSPF v3, if it's only supporting IPv6, to advertise IPv4 networks. One of the other big differences is that with a source address for these advertisements, so your v6 network, your v6 router advertises prefixes. The prefix is really the network ID, really and truly, for your IPv6 network. It's the same idea, that just the terminology is different. One of the big differences is that Your IPv4 router using OSPFv3 will provide an IPv4 interface address as its source address, whereas the v6 will use its link locals. That's why it's so important to get your link locals set up and set up correctly, because some of these messages only work on the local link. Your destination addresses, in terms of v6, there are three options. You can use FF02::5. That's the all OSPF router's multicast address. And then FF02::6. This is the DR-BDR multicast address. So for example, if a DR other router needs to talk to the DR-BDR, it will send its multicast traffic to FF02::6, which is analogous to 224.0.0.6. Another one of the big differences, when you're advertising your networks in v2, you use the network statement in router configuration mode. For OSPF v3, you do the IP OSPF and then the process ID and then the area ID on the interface you want to add. Now, if that interface happens to have multiple addresses configured on it, you really wouldn't want to do that with multiple networks, but I suppose you could. It will add the appropriate prefix to the routing process when you add the interface to that command to the interface. Another big difference, unicast routing. With v4, IPv4 unicast routing works out of the box. You don't have to do anything to make it work. With v6, we have to turn that on. In part because v6 starts doing more. Once you turn on unicast routing, once you start adding addresses to interfaces, it starts doing neighbor advertisement, neighbor discovery, router advertisement, and then it starts being able to respond to router solicitation from the clients. One of the things you'll learn in CCNA 4 when you start talking about ACLs is, whereas with IPv4, there's a single implicit deny at the end of every IPv4 ACL. There's a couple of implicit permits at the end of every IPv6 ACL to allow network discovery traffic to flow correctly, because network discovery is so much, neighbor discovery is so much a part of how IPv6 works. Even how it handles duplicate address detection and the way it handles logical to physical address resolution. There's really no such thing as the address resolution protocol per se in IPv6, but it does the same thing with neighbor discovery and neighbor advertisement. Authentication modes. I mentioned this in a previous video. OSPFv2 will handle plain text or MD5 authentication. OSPFv6 uses IPv6 authentication, which is to say IPsec, which is, shall we say, baked right into the cake. One of those things that they developed after IPv4 came out, after it was deployed into the enterprise. We figured out, okay, here's some things that don't work quite so well. What if it would do this? A couple of things I thought, hey, it would be nice if it could do X, are QoS and IPsec. Those things are retrofitted to IPv4 and included in the design of IPv6. Okay, hold on just a second. Okay, so I mentioned link local addressing. An IPv6 link local address will allow IPv6 devices on a subnet to talk to each other with traffic that cannot get off the local link, the local segment. The router will literally refuse to route that traffic. And so, whereas with EIGRP, we had what we established as bounded partial updates. This is, in a sense, another way of doing bounded updates. You make sure that your link state updates, your link state requests, your LSDB, all that stuff goes only to the neighbor devices and doesn't link too far. So IPv6 OSPFv3 uses link local to exchange those messages, keeping everything between the neighbor, within the neighbor relationships that it has already established. Now, the next thing we're going to talk about is the beginning of the implementation. We'll talk about the topology, link local, etc. So we'll be right back.